So today I want to review a few things with JavaScript's object mechanism, go over a little bit of the syntax because it's different than the C++ syntax. I know last time I went over at a high level how Java's object system differs from C++'s class instance model. This time I want to go down to the syntax and just show you how it handles the creation of prototypes and objects. And then we're going to talk about the JavaScript DOM and how you can use it to navigate through the elements of a page and also modify the content and structure of a page. So we're going to start with creating and deleting objects, and they're created and deleted using the same keywords as in C++. So you use the new keyword to create an object, you use the delete keyword to delete one. If all you're interested in doing is using an object as a dictionary, then you can create it using a set of empty braces like that. That creates an anonymous object, and you can then set things into it. So down here you can see that I have assigned two different key value pairs. So I've associated Brad with the key name and associated the zip code 37920 with zip code. And you can see also that there are two different syntactic forms for accessing the elements of an object. You can either use dot notation or you can use notation that looks like an associative array. Either one works. And then the last statement, delete new object dot name, actually removes the name property from that object. Now, the big difference you'll see between C++ and JavaScript, and actually between JavaScript and some other scripting languages, is the way that you establish a prototype. The way you establish a prototype is via a constructor function. And the way that JavaScript knows it's a constructor function is that inside of it, well, it knows it in two ways. You'll call it by putting new before it, and then it will, inside of it, to access the member variables, you will want to prefix them with the keyword this. So this is a pointer to the object created by new. And you'll note that I have not set up an object using the curly braces. That's done for you automatically by the new operator. So when you enter the function, you already have an empty object defined for you. Then you fill it by prefixing the key names with this, because this is your pointer to that object. So here I am simply initializing three of my fields to values. Then this statement right here is creating a new account object. So when it comes back, it's just a essentially hash table that has three keys in it. Now, you can also add methods to objects by defining a function and then assigning a pointer to that function to the object. So here, I might have something like increment balance. So I might have a function, debit balance. Actually, this would be a withdrawal, so debit balance amount. And I could say this dot balance minus equals amount. And then I could assign a pointer to this function to my new account. By saying new account, whoops, dot say withdrawal equals debit balance. And now I could say new account dot withdrawal 50, and that will call debit balance, passing it the value 50, also passing it as an implicit pointer, a pointer to this new account object, and it will decrement the balance by $50. You'll note that assigning debit balance to new account has actually only assigned this function to an instance of account. It didn't assign it to the account prototype. I could also have said account dot withdrawal equals debit balance. And now any instance of account would end up with the debit balance function being able to call it. That seems kind of odd. You're assigning a proper or a function pointer to a property of a function. That is fine in JavaScript because it is treating this account function as though it were a prototype object. So that's kind of odd. Now, it can get even a little more odd because you would typically declare the functions associated with a prototype inside the function. So in fact, you would typically put this function definition and nest it inside the function definition for account. So it looks a lot like a class declaration in Java. For those of you familiar with Java, you put both the instance variables and the function bodies inside the class declaration. The same thing is typically done in JavaScript by convention, not by requirement, so that all the functions associated with, or member functions associated with a particular class are grouped together in that class's constructor. And then you still, in that case, if you had put the function definition in it, you would still have to say this dot withdrawal. So it's not enough to just put the function inside of it. That doesn't automatically create a key with the name debit balance. If you want the property, if you want it to have a actual property with the name debit balance, you would have to say as a second statement, this dot debit balance equals debit balance. So that's kind of odd that the function that creates the object or the prototype is in some sense doubling as the prototype's declaration. But it makes sense if you think of the fact that the prototype is itself an object. So this function is itself an object, and it can have different properties associated with it. Okay, so questions about that? Okay, so then if you wanted to create an inheritance chain, let's say you wanted an instance of B to be have a prototype that's an instance of C, you can see that we're doing that right there. So you have a function C creating objects of type C, a function B creating objects of type B, and to make B inherit from C, you set B's dot prototype equal to new C. And again, B is a function object. You've simply set its prototype to be equal to an instance of C. Now, actually, I want to try something because thought just occurred to me. So I'm going to copy this here, go to Scratchpad, and see if I can't make B's prototype simply equal to C. Nope, that did not work. So in fact, I am going to have to set it equal to new of C to make that work, it looks like. Yep. Okay, so in fact, to make B's prototype point to a C object, you would have to create an actual instance of C and then make B's prototype point to C. And now all B objects are instances of that particular C object. So questions about either objects or how you set up inheritance chains. Okay, JavaScript is single inheritance. There's some ways you could create so-called mix-ins, but we're not going to go into it. The prototype is really meant to just be a pointer to a single object. Okay. A second, before we move on, I also wanted to say something about the lifetime of a JavaScript variable. When a web page is served, that essentially, if that web page loads JavaScript functions and those functions execute, they create state information. As long as the browser does not go to another page, those functions retain their state information. Okay, that's kind of similar and kind of different from the way PHP was. With PHP, you had the idea that a request gets served, the PHP script starts, it creates a web page, it sends it back, and now all state information is lost. Whereas with JavaScript, the function can execute, and let's say there's a form. So let's say you have some form in JavaScript, and it creates a button, or let's say it creates a text box, zip code, and let's make that quantity. Let's say there's another one for price. And let's say that each of these has an onClick method that computes price or compute total. And the same thing down here. And let's say that in the script you have function compute total. And now you decide that you actually would like the variable it computes total to be a global variable. In here you have total equals, say, document dot, say this form's name is invoice. So it would be document dot invoice dot, let's say, quantity times document dot invoice dot price. And after this function, let's say we entered a quantity here and it executed, and initially price, let's say, is 0, so that leaves total with a value of 0. That value continues to exist after the function terminates. Now we change price to be 1.5, and again the function gets called and it changes total to 15, and again total's value persists as long as this web page is the one that is still in our browser. So, or being displayed by our browser. So the state information is persistent in a JavaScript program until some other web page comes in and replaces it. When the web page gets reloaded, then JavaScript, whatever JavaScript functions there are, get reloaded with it, and any state information gets lost. Okay? Okay. So, you'll remember that last time said that the main way that JavaScript interacts with a web page is through the DOM. So every time a web page is loaded, the browser parses the HTML markup and creates a tree with objects that can be accessed. And this tree is called the DOM object. So each time the browser loads a page, it parses the HTML markup and creates a tree of objects. This tree is called I'll just put JavaScript /HTML. Technically, it's the HTML DOM object. So this is document object model. All browsers create a pointer to this document object model called document. So document is the variable created by all browsers to point to this tree. And this DOM object defines a whole variety of methods that allow you to navigate the tree, that allow you to alter nodes in the tree, and allow you to alter the attributes of objects in the tree. And by every time you make a change, the browser will automatically update the web page based on the changes that you made. Okay. Now, you saw it last time, but I'll repeat it. The nodes that contain text content, so as an example, what appears between the P markup for paragraph, you can get at that content via the .inner HTML property. Now, this is kind of an informal property that all browsers support. It's not, as I understand it, actually in the W3 standard, but it can be relied on to be there for all browsers. And it allows you to get access to the content of a particular HTML element. Now, in order to either access that content or to change it, we first need to be able to retrieve or to gain access to the node that points to the object. So these methods that you see here, these methods allow you to gain a pointer to the element you want to modify. So the most common, and I am also showing you the, I would call it assembly language way to get at the DOM. Generally, you would use a library these days to interact with the DOM object. A popular one is jQuery. We don't have time to go into that, and I also think it's important that you know what the guts of a DOM object looks like. But it is, just like assembly language is fairly verbose to it, or you have to write a fairly verbose program to accomplish anything with assembly language, the same thing is true of the DOM. You have to write fairly verbose code to do things with it, and so people have developed frameworks, libraries that make it a lot simpler to get at these objects. However, that's what we will be looking specifically at the DOM's way of getting at them. So probably the workhorse is this getElementById method. You give it the value of an element whose ID is the target element, and it will return a pointer to that element's node. Obviously, you expect the ID element to be unique. There's also ways to get to all of the elements that are in the same class. So there's a class attribute that allows you to create the CSS, cascading style sheet equivalent of a class. And they, as a class, instances of a class do share common style attributes. Typically, you don't need to get access to all elements of a class, but should you need to do so, this would allow you to do it. I guess one reason is you might wish to change some color attribute or some style attribute of all of the objects in that particular class. Okay, although I would not be surprised in that case if there isn't a way to change the class object itself. Okay, then there are certain HTML items that are placed in arrays to make it easy for you to get access to them. So all forms are placed into an array. All anchors, so anything that starts with the A link, is placed in an array. Anything that starts with an IMG tag, and anchors are links are also A. I'm not going to get into the difference between an anchor and a link, but there's ways to tell the difference between an anchor and a link, even though they both start with A. An anchor gives you, in essence, a link into some other point in the same page. A link gives you a link to an external page. So they both start with A, but then using some syntax, you distinguish between whether this is a link to some other part of the same page or a link to an external page. So each of these four attributes points to an array, and then the name attribute, so remember with a form, you use the name attribute, not the ID attribute. So in this case, the name attribute is used to gather together these items into a common array. And then the last thing you might do is get elements by tag name. And you might think, what's the difference between class name and tag name? Typically, I might have paragraphs that start introductory sections. So I might have a class name that is introductory paragraphs. So you might have some set of paragraphs that are subset of all paragraphs in your document, and they are introductory paragraphs, and they might start with some different kind of formatting. So if you want to get all nodes that have the same tag name, document.getElements by tag name will do it. So for example, I might want to iterate through all the paragraphs in my document and print their content. I could do that using this code right here. So it returns what's called a node list. I can iterate through that node list and access the node list as though it were an array. As you can see, I'm writing out each of the contents of the paragraphs using the inner HTML. Now, obviously, I'm using document.write, which would mean I would be destroying the existing web page and replacing it with a new web page that contained all of the content in plain text form. So these are some of the ways you get access to elements in the tree, the so-called ways of querying the tree. So these might be called methods, query methods for the tree. Okay. So then, the second thing you would like to do is to be able to change the contents of the DOM object. Remember, write is a pretty bad way to do it. I have it there because it is one way to do it, but it destroys the current contents. These remaining three methods, though, are pretty commonly used. The first one changes the content of the tag represented by that node. So whatever tag element is represented by this ID, its content is being replaced with whatever is on the right-hand side here. So in this case, I'm querying for an element whose not tag name, whose ID is question 1, and I'm changing its content to new question. Okay. If I want to change an attribute, then I do the same thing except I give the attribute name. So here I'm changing the image being displayed by this particular tag. So this is changing its source to point from whatever image it currently points to an image named landscape.jpg. And the document would download this JPEG file from the server. It's presumably in the same directory that the HTML page resides in, downloads landscape.jpg, and displays it in the browser. And then if you want to change the style of the element, you go through its style object. So all elements have a style object, and you can change different colors or different properties. So in this case, I'm disabling an element which is named beneficiary, and I'm changing the color of the text in this particular tag to the color blue. Okay, and this is fairly common thing to do. So for example, in Code Assessor, let's say that I am creating an exam problem, and I need to fill in certain fields like the date, start, section. Well, I'll just hit OK, and you can see that it has seemingly popped up some error messages indicating that what I need to do. I need to enter a date, I need to enter a start time, I need to enter a section. Well, it turned out that these these content tags already existed, and I'd simply had their visibility hidden. And when I discovered there was no date entered, I changed their visibility to be displayed, and now they pop up. Okay, so let's see if I can't find that in very quickly. Okay. See if I can't find it then in the page source. Okay. So you can see that in my page source, I have a line there that says span ID equals exam date error, class equals form element error message, and then please enter a date and the end of the span. Now, you'll see this is something that I can get to using a cascading style sheet. So it's called form error message, form element. And if I go there, you can see that it has two attributes, color red, display none. Display none means that it's initially invisible. So while you didn't see something that said visibility hidden, or none, initially it's just not there. Now, when I want to make it visible, I change this display attribute, and I change it so that it has a visible value, and now the attribute or the content appears. So going back to here, that's another attribute that you can change in the style, the display attribute, and that can control the visibility of something. Okay. Now, that changes content. You also might want to change the structure of a document, and you can do that with a create element method. Give it a tag name of any type, and it will create an element with that tag name. Now, that has not yet put it into the document. It's not yet added it to the tree. You add it to the tree with one of these, actually 3 commands. Okay, so let's say that you have a tree. Looks like this. Okay, I'll say I have P1, P2, P3. Let's say I just created this new element, and it's a paragraph. And let's say that I set its ID, so I might say then new paragraph dot ID equals P4. Now I want to insert it. If I want to insert it before P1, before P2, or before P3, I would use the insert before method. And notice it's no longer document. It's now the parent node. So I would need a pointer to this parent in order to do the insertion. So I would have a pointer to this parent node, and then I would say insert before, and new element, in this case, is new paragraph. And I would also need to have a pointer to target. So whichever target I was coming into, I would also need a pointer to it. If I want to append, if I want to put it here, that is going to use append child. And if I want to replace, let's say I want it to replace P2, then I would use the replace child command. So that would actually replace the node. Now, obviously, I could have simply changed the inner HTML attribute, and that would have been simpler. So presumably, I'm replacing it with something that is a different kind of markup object. Maybe it was bold-faced before, and now I want it to be italicized. And so I'm replacing a bold-faced element with an italicized element. And then finally, I can remove a child by giving the name of the parent and removing it. That does not actually delete the node from your JavaScript program. It will get garbage collected once nothing else points to it. But it doesn't actually delete it. As long as there's any variable that points to it, it will continue to be in your program. So questions about creating stuff? Okay. In that case, do you have enough? Yes, you do. I want you to try it yourself. So what I would like you to do is actually go to my web page and copy this particular little piece of code, and then go to a local text editor. So you don't need to do this on the Hydra machines. You can do this locally. I'm going to do it in Emacs. Okay, but you should do that on your own local machine. So you'll need to put it into your own HTML file. Not like that. So copy it, and now what I want you to do is make the changes that you see there. So just experiment with it and try each of these things. So things like appending, create the script you see right here, copy it in, see what happens, then do each of these other little experiments that I have down here so that you get a feel for how you're creating things. Now to test it, if you're not sure how to test it, whoops, what you can do in your browser is, now let's, since it may be hard to read, enter file, single colon, and then 2 forward slashes, then a third slash with the path name to your particular file. So in this case, I was storing it in users BVZ CS465 play foo.html. So as you make each modification, try reloading the page into your browser, make sure it works. So just walk through it. If you have questions, raise your hand. I'm going to give you about 10 minutes to just work through these exercises. So you're going to have to do this perhaps on part of the homework. So again, just kind of work through these things, add this stuff, and see what happens. Okay, so this is only half the puzzle. Okay, this allows us to change the content of a page, but it's not interactive. You just put the script at the end of the page and it added some new stuff, but that's really not what you're normally how you're going to be using JavaScript to modify the page. You could have done that with PHP back on the server side. What you really want to do is change the page in response to some kind of user interaction with the page. So the other half of the puzzle is adding event handlers so that when the user interacts with the page, which they do via events, you will have these DOM modifying code fragments embedded in functions that will get called when these events happen. So every element has a set of events that are associated with it. Now, we'll go over a complete set of those events on Tuesday, but we'll go over just an example here, which is a button object. So a button object, one of the events it has associated with it is the on-click event. Last time with the text box, I showed you an on-change event. So these are properties that by definition point to functions, or that the browser expects to point to functions. And these functions are expected to be JavaScript functions. So here we have an example, and I have put all of that into the actual HTML document. So you can see I'm creating a button. Actually, first of all, I created something called my heading. It has ID equals ID1. Now I create a button whose ID is big red, but that doesn't really matter. On click, and now you see some JavaScript code. Document.getElementById ID1, so it's getting this node associated with my heading 1, and I know that because its ID is ID1. And I'm setting its style, the color in its style object to be red. And then the button is click me. So you can do this yourself if you want, or you can just watch as I do it. And when I view the contents, I have a nice button, and when I hit click me, it turns red. Okay. I can also, to show you how it maintains state information, now I'm going to move it to a function. So typically you put your functions in the header. So I'm going to move this now to the header, and I'm going to say onClick equals handle click. So up here in the header, function handle click. Now, what I'm going to do is I'm going to define a global variable named color. Initially, I'm going to set it to be red. And I'm going to say if color equals red, color equals green, black. Then I'm going to set the color to be red. I'll set color to be red. Else, I'm going to set the color to be black. Okay, and I know very well that this color variable is unnecessary, but I'm doing it to show you that state information gets retained. Because clearly I could have just said, instead of if color equals black, I could have just said if that was equal to black. There's really no reason to have color equals black. So the only reason I'm doing it is to show you the persistence of state information. Okay, so now again, I'll reload it, and this reloads the page. You can see there's an error. How do I know there's an error? my button disappeared. Okay, you can use on Firefox, you can go to Web Developer under Tools. You can look at Web Console. Oh, really? There's no error message. That's kind of surprising. Let's see what my error is. Yeah, I close it right here. Oh, yeah, you're right. I never did close it. Thank you. I see what you're saying. Wait a minute. Yeah, I see what you're saying. There. That closes it. Thank you. There we go. So click me. Oh, come on. There we go. So I'd had a bit of a bug initially. The bug being the color wasn't initially red, it was black. Reload it. There we go. Okay, so the moral of this is what you typically do is you put the JavaScript that you want to handle your events, you put it into a function, and then you have attributes that are defined for those events, and you associate these callback functions with them. Now, you often do not put this into the page source. The reason is that someone can look and find that information. So typically, you are importing files into, so instead of it being here, you would put it into a JavaScript file, and then you would import it. So, as an example, there's no import statement. Come on, I need an import statement. Huh. We do it here, TTD. There we go. So normally in your header statements, what you actually see is something like this, where it says script and then source, and it gives the name of a file. And that imports the functions from that script into your HTML file. So you put these script elements into your head, so that's your header, and your header information always comes before any of your HTML. And that way, no one can pry and look at your code, because otherwise you're putting your implementation out there for everyone to look at. And often instead of putting onClick equals into the page source, you actually will do it inside of these functions. So if we go back to the web page, you can assign functions like this. So this is actually creating an anonymous function. But you can see that I get the element, big red, then I said it's onClick, and this is an anonymous function. You can see I'm not naming the function. I'm just saying it's color equals red. And this is pretty common to use anonymous functions. Does anyone know why? because it's so much easier to read than to have to flip back and forth between multiple files in order to find what this 1 or 2 line function does. So if it's a 1 or 2 line function, you typically just use an anonymous function to do it. If it's a 10-line function, yeah, you put it off in some other file or someplace else in the file so that you don't clutter up the current function. But there's this notion, again, in psychology that every time you have to break your focus by going to a different part of the file, it takes at least 15 seconds for you to reestablish your concentration. So that's 15 seconds blown on each end. So it's a 30-second round trip plus finding where that function is somewhere in the else in the file. So you've lost probably 45 seconds to a minute trying to find where this function is and what it does, whereas if it's inline as an anonymous function, you lose 0 time with your navigation and loss of context. That's why anonymous functions are so nice and so heavily used in both Java and JavaScript. But this is the magic sauce that allows you to take, so I was just changing a style attribute, but I could very well have taken what was done earlier and put that into a function as well. So in fact, let me do that now. And I'm just going to I'm going to take it and handle click. Instead of changing the color, what I'm going to do is add a new element to my file. So when I handle click, I'm going to take this code here and I'm going to put it after the button. As the parent, there is no real parent here, so let's create a div. Actually, let's just put it after, no, let's create a div. Call it ID equals block. Put the div here at the back. So now, instead of it being called div1, it's called block. So I'm creating an element, creating a text node, adding it to the paragraph. So this creates a new paragraph element. This creates a new text node with the content. This adds the content to the paragraph. This retrieves a pointer to the block div. This adds the paragraph to the end of it. So if we now make this puppy visible and click it, you see I get my new paragraph. And for grins, we will make this instead, we'll call it add equals true. So we'll say if add, else we will remove it. And we need to get a pointer to the thing we want to remove. and I did not name it, so I'm going to name it up here. So I'll name it para.id equals new para. So now down here, I can locate it using new para. And I have, we'll call element, instead of element, we'll name it parent, just to make it clear it's a parent. Parent.remove child. And finally, we set add equal to not add, so that it's the opposite. So what should happen, provided I did all of this correctly, I'll put it back in a moment. I just want to test it. There it shows, there it's not. There it is, there it's not. Okay, so that's the code that allows you to do that. So questions about how you basically interact with the DOM, or two, how you set up this event handling so that you can call the functions that interact with the DOM. Okay. But this was basically the idea, is that you would have form elements. When the user interacted with these form elements, they would call JavaScript functions. The JavaScript functions would make changes to the DOM, and then the web page would get updated. So this JavaScript was adding interactivity to web pages. Now the very last thing is you can make this a little bit easier. Instead of having to create a text node and append it, I could simply have said para.inner HTML equals this is a new paragraph. And it would have worked equally well. So I think that's a little bit clear. If I do it, this is a new paragraph. So you can replace those two lines by simply saying .inner HTML equals, and it's all good. Ooh, this makes me think, what if I did this? Never tried this ever. There's always a first time. Nope. Too bad. Okay, don't do it, whoops. Do not do it this way. It doesn't take a second parameter. Okay, so on Tuesday, we are going to get into event handling and form validation. So JavaScript, one of the big things it does with form handling is form validation. And how do you think we do form validation? Come on. Well, with JavaScript, but what? With what? Well, events call something, and we then we validate the stuff using, from Perl? Regular expressions. Very good. So we'll be going over JavaScript's version of regular expressions and the types of functions that the event handling that is supported by the HTML DOM. And if we have time, we will get into Ajax